The charges that move through the main part of a parallel circuit split when they come to the branch in the parallel circuit. Some go through one branch, others go through the other branch, if there are two branches. And then when the branches join, the charges join again. Let's take some measurements to show that this is really so. Here we have a simple parallel circuit. The circuit has a 9-volt cell and an LED in the main part of the circuit. In the branched part of the circuit, there are two resistors in parallel with one another, a 22K and a 2K2 resistor. Here we have an ammeter positioned in the main part of the circuit, in the part before the branch. It's measuring the current strength flowing through it in the main part of the circuit. We could call that I main. We can see that the measurement is 3,86 milliamps. Now we move the ammeter into the positions shown here. So now we can measure the current strength through each of the two branches. We see that the current strength through branch 1 is 0,34 milliamps, and the current strength through branch 2 is 3,52 milliamps. Notice that more current is flowing through branch 2 than through branch 1. Around about 10 times more. 3,52 is roughly 10 times more than 0,34. Why is so much more current going through branch 2 than through branch 1? It's because branch 2 is easier than branch 1. The resistance of branch 1 is 22K, 22,000 ohms. But the resistance of branch 2 is only 2K2, 2,2K. In other words, 2,200 ohms. 22 is 10 times more than 2,2. That's why 10 times more current strength goes through the easier branch. But there's something else that's interesting here. Notice that if we add these two numbers together, 0,34 plus 3,52, the answer is 3,86. Where have we seen that number before? That's the current strength in the main part of the circuit. This isn't surprising because the current in the main part has split into two. That's why when you add the two branches currents together, you get the main part. In other words, I main is equal to I1 plus I2. 3,86 is equal to 0,34 plus 3,52. Let's check if you've really got that. Let's pretend we have a circuit here where we measure 3 milliamps in the main part of the circuit and 1,5 milliamps in branch 1. What must the current strength through branch 2 be? Remember that this 3 milliamps is splitting into the current through branch 1 plus the current through branch 2. I main equals 3, and that equals I1 plus I2, where I1 is 1,5. What must we add to 1,5 to get the answer of 3? 3 is equal to 1,5 plus 1,5. Notice that in this case, there's an equal current strength through each of the branches. The current splits equally, and that's because in this circuit, each of the two branches is just as resistant as the other. The resistance is the same in branch 1 as branch 2, 22K for both. That's why they split equally. Let's have another question. Let's say now you need to find out what the current strength is in the main part of the circuit when you are given what the current strength is in each of the branches. In branch 1, there's a current strength of 3 milliamps, and in branch 2, 6 milliamps. So what must the current strength in the main part of the circuit be? I main equals I1 plus I2. What must I main be if it equals 3 milliamps plus 6 milliamps? Well, of course, the answer is 9 milliamps. The 9 milliamps in the main part of the circuit splits into 3 milliamps through one branch and 6 milliamps through the other. Notice that in this circuit, double as much is going through branch 2. than branch 1. Why is that? That's because branch 2 is much easier, half the resistance. Its resistance is only 5k, whereas branch 1's resistance is 10k, which is double as resistant.